Good morning, everyone. How are you guys doing today? We are almost done. After today, we'll be done with the syllabus. So whatever we have, nothing new. We are going to revisit everything as much as possible after our fifth exam. So after the fifth exam, next week we have only 2 classes, Tuesday and Thursday. And I'm planning to hold an online review on Friday, if you're willing. So you don't have to be here. We can just do it online. What do you think? Are you guys interested? Yeah. Okay. So our exam is this week, Friday. And we are supposed to do a review on Thursday. Unfortunately, I cannot do that. I have one of the final on Thursday. So I was planning to take the entire day for that. So instead of doing a review, I'm just today going to tell you what will be in the exam. Basically, I'm giving you the exam today. Okay. So after you're done with 11.4, before you leave, I'm going to tell you what exactly will be in the exam. Study those questions, it'll be fine. What do you think? No. That's why instead of doing a review on Thursday, I'm going to just today I'm going to just tell you what will be in the exam. So study those and then you'll do great. Any other question from anyone? Only this test, okay? Then Friday is your exam. And when you come back on next Tuesday and next Thursday, you're going to have a review. And next Friday, whatever we are missing this Thursday, so I'm going to make up that class on Friday for the review for the final exam, as a review for the final exam. Okay? Okay, so far in chapter 11, we talked about quadratic and we learned all about quadratic. How do we solve them? We use 3 methods. Either we do factoring if it's factorable. If it's not factorable, then you have 2 choices to solve, either quadratic formula or complete the square. In quadratic formula, whatever we have another radical, it's called discriminant. And discriminant tells us how many solutions we have, what type, real or imaginary, and how about the x-intercepts. And then we did transformation, if you remember. Transformation has, for now, we are learning 3 types of transformation. One is a negative sign in front of the function. It means you're flipping your parabola upside down. And then whatever number you have inside your parentheses, it goes left, right, but it doesn't follow the direction. Plus supposed to go right, but it doesn't. Plus means you're moving left. And minus supposed to go left, but it doesn't, it goes to the right. And then whatever you have the number after you square, it means you're moving up or down, and it listens to the direction. Plus means you're moving up, minus means you're moving down. And then the last thing we did in our class was going the reverse direction. The parabola is given, find out its formula. So we start by Bartek's formula, the Bartek's format, and then we replace x and y, any xy from the function, and then h and k means this is the Bartek's. Then you solve for a, and then resubstitute a, h, and k. I really want to give this question in the exam, but I don't have space, so I'm not going to give this in the exam. But this question sometimes comes in the final. Sometimes, not always. So for final exam, yes, you should remember the strategy, the solving methods. And now you're going to our last section, 11.4, where we are going to work with inequalities. So all these times, whatever we did, we use equal sign. So when you solved, we got either no solution, 1 solution, or 2 solutions for quadratic. Now, when you're working with inequality, we're not going to get one or two solutions. We are going to get a set of solutions. It means in an entire interval, if you pick anything from that interval, that will satisfy the condition. So not one number, two number, three number. It's an entire set of infinitely many numbers. So this is the difference between having an equal sign and having an inequality. Equal sign gives us limited number of solutions, 0, 1, or 2, but inequality gives us a set of solutions where we have infinitely many numbers that satisfy our condition. And we have 4 types of inequality. Either less than or 0, or it's too small. Let me write it bigger. Either we have less than or 0, or we have only less than, or we have bigger than or equal, or we have only bigger than. There are 4 types of inequality. Wherever we have the mouth, that side is bigger. You know that, right? Whichever has the mouth, that is bigger, and whichever has the pointy side, that's smaller. Now, the important note here is that we must set out numbers to find the correct solutions for inequalities. So what does that mean? Well, first we are going to do some quadratic examples. So we don't need to do this for quadratic because my plan is to show you the graphing method. With the graphing method, you don't need any math. Just graph your quadratic and you see the solution. But once you're done with quadratic, we're going to do rational. So for rational, we don't know the shape. For quadratic, we know it's a parabola. But for rational, we don't know. That's why whatever solution we get, we place them in the number line. Here, 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 whatever solutions we have after solving for x. And we have negative infinity, positive infinity in the number line. And then we pick one number from each interval, submit it into the function, and see which interval gives us whatever we are looking for. If you have bigger than or equal, it means you're looking for positive, including 0. If you have only bigger than 0, it means you're looking for only strictly positive numbers. If you have less than or equal 0, it means you're looking for something negative, also the 0. And only less than 0 means you're strictly looking for negative numbers. So depending on whatever you have in your inequality, we look for different things. And in order to see which one we have, we take one number from each interval and see which of these intervals gives us whatever we're looking for. Now, since we're going to have a set of numbers, so every set or every interval have two endings. Either we have a parenthesis or we have a bracket. So if your inequality doesn't have any equal sign, only strictly inequality sign, all the answers are going, all the solution are going to have the interval, the both ends have to have parentheses because there is no equal sign in our inequality. However, if inequality has an equal sign, then our boundary, the boundary of the set, the interval, will have brackets. So equal sign gives us bracket. No equal sign gives us parentheses. And now let's do some example. Let's start with something easy. We have negative x squared plus 4. Now we are looking for bigger than 0. Bigger than 0 means what we are looking for. Which type of number we have bigger than 0? Positive. We are looking for strictly positive. Strictly positive numbers. Strictly positive numbers, we have them above the x-axis. So let's graph this. Now, negative means which type of transformation? Upside down, good. And then after you square, you have a plus 4. So which direction you are moving? After the square. up. Left, right is inside your square. If you have a number after the square, it's up, down. So we are going up 4. So the original one is here, and you're moving this original one. Sorry, first you have upside down, and then this upside down, you're moving 1, 2, 3, 4 here. Now, when you do transformation, you get the graph, and we are done. But here we are not done because we have to know exactly where we are crossing that axis. We need to know this number because this number is going to tell us what is our interval. So before we find this number, we are looking for something positive. So does this give us a positive y? Does this give us a positive y? Does this give us a positive y? Yes. So our solution definitely is this part. Positive y value. So only this gives us positive y. So we want to know exactly what these numbers are. So you look for x-intercept. Do you remember how they find x-intercept? To find the x-intercept, what do you do? Set y to be 0, right? So negative x squared plus 4 equals 0. And our goal is to solve for x. We can add the x squared to both sides. So it will become positive. We get x squared equals 4. And then to get the epsilon, what do we do? Square root, perfect. So we get x equals. But 2 is only one solution. We are looking for 2 solutions. So what is missing? Plus minus. Anytime we take the square root of any variable, we're supposed to have 2 solutions. One is plus, one is minus. So the 2 answers we have, the 2x intercept is minus 2 and plus 2. That means here C and here. What is the left number? Plus 2 or minus 2? That means here we have plus 2. Come on. Bless you. So this is minus 2 and this is positive 2. So what is our solution? Negative 2 to positive 2, right? Whatever we have from negative 2 until whatever we have to positive 2. Now, does our inequality have the equal sign? So if we don't have the equal sign, what type of boundary is supposed to have? Parentheses. That's it. If you use a graph, you don't need the number line. If you don't use graph, then you have to find the number line. But graphing is easier. You don't have to waste, you don't need to take much time to graph it. It was a little bit confusing, right? Let's do a few more. Oh, since we are doing this, let's also do the other part here. It's the same question. The only difference is here they are looking for less than 0. Same question, right? Negative x²+4. So in this parabola, which portion is lying? Which portion has negative numbers? Oh, less than 0 means what you're looking for? Negative, strictly negative. So which portion in the graph we have on the negative side? Negative means y is negative. On the left and on the right. So for this, our solution, so this is B, is negative infinity. So we have negative infinity here and positive infinity here, right? On the x-axis. Do you see? So we have -3, -4, -5, right? So all the negative numbers are going on the left. Here we have +3, +4, +5. All the positive numbers are going on the right. So the smallest negative is negative infinity, and smallest positive is positive infinity. And when we are looking at the solution, we are looking at this y value gives us which x values. The solution means the x value. Which x value satisfies this condition? So we know y values are here, but we are not looking for y values. We are looking for negative y values gives us which x values. So from here to all the way to the other side, we have negative y values. So we have negative infinity to -2. All of these x values gives us negative y values. Also from -2 to positive infinity. Whatever we have here, all these x values gives us negative y values, right? 3 gives us this number, 4 gives us this, 5 gives us this. So all these x values gives us all the negative numbers. All of these x values gives us the negative y values. Since we don't have the parenthesis equal sign, so all of them will have parentheses. And we have 2 intervals, so we connect them with an union. This is infinity. So for B, our answer is the green part. Negative infinity to -2. All these x gives us negative y, and you're looking for negative y. And also there's another part, from positive to infinity, all these x values gives us negative y. So we combine the 2 ending, and we get the solution set. Let's do a few more examples. It will be easier. First thing, observe, we have the same question. Negative x² -4 to negative x² -4, the same question. The difference is this. In C, what you're looking for? Something positive or something negative? Positive. So you're looking for positive y values. Positive y values. But on D, what you're looking for? Negative y values. So let's draw. Negative means negative x² means what? Upside down. And then you see a -4 after you square. Down 4. So let's draw the graph. We have -1, -2, -3, -4, -5, and then the very last we have -infinity. +1, 2, 3, 4, 5, 6, and then +infinity. So we have a downward parabola down 4 units. So 1, 2, 3, 4. Our new vertex is here, and this is the parabola. This is the original one. We are shifting the original one upside down, and then 4 units down, -4. Right? This original parabola upside down, and then 1, 2, 3, 4 units down. Right? Transformation. I did nothing, just transformation. Now, by observing your graph, which portion of the graph is lying above the x-axis? Which y values are positive in the graph? Is there any y value which is positive in the graph? So what's the answer for this question? 0 is a number. Infinity is also a number. None. There is no solution. So the answer for this question is no solution. Because there is no portion of the graph which is lying above the x-axis. There is no positive y in this graph. All the y you see, all of them are negative. So now here, they're asking for negative y. So what's the answer for this question? Until -4, you're giving me the y value. You observe the y value, but the solution has to be x values. For which x values in y is negative? So for 0, y is negative, right? For -1, y is negative. For -2, y is negative. For -3, y is negative, right? For -infinity, what is your y? Still negative, right? It doesn't matter what number you pick, all these x values gives us -1. Now look at this side. For 1, this is negative. For 3, this is negative. For 6, this is negative. That parabola is going on forever. Okay, I don't have space to draw, but it's going on forever and ever. So if you go to here, the infinity for x value, what should be y value, positive or negative? So for which x values your y is negative? From which value to which value? See? So entire number line. The answer for B is -infinity to +infinity. When you give the solution, we give the x. But what do you observe? The y's. Is it a little bit clear now? Let's do a few more examples. And again, observe, we have the same question, just inequalities are different. X plus 3 square, x plus 3 square. So we don't have any negative in the front. We have only +3 inside your square. So which direction you are shifting? Up and down is after you square. Left. So this is the original one, x squared. We are shifting this original one 1, 2, 3 units to the left, and we are drawing here. Take the original parabola, shift 3 units to the left. Now let's see what they're asking for in A. What we are looking for? Strictly positive, right? So if you have y equals 0, does it count? No, because they're looking for strictly positive numbers. So for which x values you see all the y's are strictly above your x-axis? Definitely goes up to infinity, right? Negative infinity. All these numbers from negative here are y's above the x-axis. Right? All these y's are positive. So you definitely get negative infinity to negative 3. Right? But when x is 3, what is in y? Why it's not this way, negative 3. When x is negative 3, how much is in y? 0. Are they asking for 0? No. That means we cannot highlight here. We have to highlight after 3. So even though we have basically entire portion of the graph is positive, but there's only one place that you cannot have in our solution. That's the 0. When y is 0, we cannot have it because there is no equal sign. So we have to split our parabola into 2 pieces. One is before negative 3 and one is after negative 3. But we cannot take negative 3 because negative 3 makes the y value 0. So we have negative infinity to negative 3 union, not comma, negative 3 to positive infinity. What would be their boundary? Bracket or parenthesis? Parenthesis because there is no equal sign. Infinity always gets parentheses, always. And for the numbers, either it's bracket or parentheses, it depends on inequality. So this is what it means is that take any number from negative infinity to negative 3 for the x value, substitute, and you'll see your y is positive. Also take any number from negative 3 to positive infinity from the x values, substitute here, you'll see the y value is positive. But you cannot take negative 3 because negative 3 makes the y value 0. Okay? Now look at the next part. What you're looking for. Less than or equal 0. Of course, negative. Anything else? Equal 0 says. So you're looking for also 0. Negative and 0. For which x values your y is negative or 0. Do you have any negative? Now, negative y value here? Do you have any negative y value in the graph? Our graph is not line. Negative y means the y value negative, Muhammad. Do you have any y value negative here in this graph? No. Because all the y's are positive. Yeah. But do you see any y value which is 0? No. Yes, our y is 0 here. Y is 0 here, y is negative here, y is positive here. So observe the y, but give them the x. So we don't have any negative y, but we have a 0 y. So which x gives us a 0 y? Negative 3. So answer here is x equals negative 3. Only one answer, that's it, only one thing. So for only one, we use this notation, curly bracket. For interval, we use bracket or parentheses. But if you have only one number, we represent it with a curly bracket. So say same parabola, but based on your inequality, we can have different answers, different solution set. You see, this is not one number, the solution set. This is not one number, the solution set. Only here we have one number, but we represent that as a set. It's a set with only one number. Is it a little bit better now? Let's do a few more. Now, let's say we have x squared minus 3x bigger than 10. What do you observe here? Something is missing, right? Compared to all 4 examples we did so far, 4 or 6, whatever, 0 is missing. So we have to have a 0 on one side. Do we have a 0 on one side? So what is our first step? Subtract 10 so that we can see 0. Minus 10, minus 10. So we have x squared minus 3x minus 10, bless you, bigger than 0. And now graphing this is hard, right? Because all these examples we did so far, they were in Bartek's form. So we use transformation. But this is in standard form. So instead of just graphing, we want to see what is our x-intercept. But without even doing anything else, just by observing the x squared, what do you think the shape of our parabola? Upward or upside down? Upward. Good. We definitely know we have an upward parabola. We just want to know when it crosses the x-axis, what are those numbers? So you're looking for x-intercept. In other words, our goal is to solve for x. So to solve for x, we have factoring, we have complete the square, and quadratic formula. Which one do you think is easier here? Factoring. Can you think of two numbers when you multiply, they become negative 10. When you combine, they become negative 3. Good job. Negative 5, positive 2. So this gives us x equals what? Positive 5. And this gives us x equals what? Negative 2. So now we know. We have an upward parabola, negative 2 here, 1, 2, 3, 4, 5 here. And we have negative 3, negative 4, up to negative infinity. And here we have to positive infinity. So the graph we are drawing has x-intercept here. It's an upward parabola. Now let's see what we are looking for. Bigger than 0 means positive y or negative y? Positive y. So which part of our parabola is giving us the y value positive? Good job. This portion is positive. That means the x value is lying here on the left side. The positive y is here. So solution set gives us the x must be on the left. And then we have another positive y is here, right? So this gives us the solution set for x is 5 to infinity. So solution negative infinity to negative 2 union 5 to infinity. Infinity always gets parentheses. And for negative 2 and 5, do you use bracket or parentheses? Parentheses with no equal sign. Equal sign means bracket. Otherwise, it's parentheses. So take any x value from negative to negative 2, replace here or the original function, you'll see all the y's are positive. Same thing, take any number from 5 to infinity, replace into your function, you'll see your y is positive. So our solution is this set. And guess what? This is the finalized question. You'll have at least one. Now, do you feel a little better than before? How do you find this? Okay, now try, this question here. Try this. They look same, but definitely they are not same. You don't have to do it alone. Talk to your neighbors. This is one axis. Which one is supposed to be? Oh, so if you pick it up like that, But any number of negative 5, everything that all the ones are just how many resolve this? All the accident is that includes only the numbers of the accident. So what is this number like down? No, this is excluded. It means the numbers 5 the number
Remember this. It's
yes, we have to find out in the same transformation. But again, is
when that happens.
We know this apple model so we are going to gas has activated the fire and so the value is upward so this has to be
Until the first exam. So
so which side is the right he's writing that here. One. Is it why making here? Is it why making here? Which is all the numbers negative 5, negative 4, negative 3, negative 6, 1, all of these numbers is going to be so in the last we have made 5. If any numbers in this instance, okay, you observe the y that you give the x. For which x reduce the y is going to be. So fundamental is and so maybe because here you have to we can eventually have to so you're looking for which is the one that's
this is good. That's why
so easier is when it's
yeah, but right now
so from which x for every x
we're looking outside. For this incorporate
next 5 times Okay. So in the exam, I'm going to ask you this type. Here.
That exact question.
Not the exact question, the format. So here I wrote down all the steps. First, we have to see 0 on one side. If you don't see 0, we always have to see 0, so we subtract 10. And we get x squared plus 3x minus 10 less than or equal 0. Second step, factor if possible, and then solve for x because we are looking for x-intercept. So is it factorable? Which two numbers multiply to negative 10 combine to positive 3? Positive 5 and negative 2. 5 has to have the bigger sign. 5 has to have the middle sign because it's bigger. So if you're trying to solve for x, you get x plus 5, 0, gives us x is negative 5. This is one x-intercept. X minus 2, 0, that gives us x is 2. This is another x-intercept. Why do we care about the x-intercept? Because in order to graph, we need the x-intercept. Previously, we didn't need the graph because we used transformation. But now we cannot use transformation. It's not in vertex form. So we graph. We know we have negative 5 and positive 2. Decide the shape of the parabola. What type of parabola you have to draw? Upward or upside down? Upward. So draw the parabola. And then which y values you're looking for? So we look at the inequality. What type of y you're looking for? Positive y or negative y? Negative y. And also 0y, right? 0y and negative y. Now, in this portion, is it y positive or negative? On the left, this y, all these y values, positive y. All these y values, positive y. And how about in the middle? All these y values, negative. So for these y values, which x values we used? From which number to which number? Negative 5 to 2. What type of ending we want? Bracket, I mean, not we want, we have to put bracket or parentheses? Bracket, because equal sign. And that's it. Look for what you're looking for in the inequality, and then observe which x gives you that specific y. Any question? So we use graphing method only for quadratic because we know quadratic means parabola. So this will be in the exam. And now something is not quadratic. This is not quadratic because we have 2, 3, 4 power. So we don't know the shape of this thingy function. So that's why we cannot draw a parabola. We are going to learn a second method of finding solution. In this second method, we are going to find all the x-intercepts, place them in the number line just as we did here. And since we don't know the shape, we are going to pick an x value from each interval and see which interval gives us the y we are looking for. So number line method. Use number line method for everything not quadratic. Anytime you have anything that is not quadratic is number line. So our steps are same. See 0 or get 0 on one side. Factor. Solve for x. Place them on the number line. Check each interval. And then we have more steps, but I don't have space here. So we have to decide which y value we are looking for. And then we take from each interval an x value, substitute and see the y values. Let's do an example. So fortunately, we see 0. We are happy. And also all of these are already factored. So you don't have to do first and second steps. We are going to the next step. Solve for x. So x squared equals 0 gives us x equals what? 0. This is our 1x intercept. X plus 1, 0, we get -1. This is another x intercept. X minus 5, 0 gives us x equals +5. So we have 3 x intercepts. So we solve for x. What are we looking for? Positive y or 0 y? Right? Two types of y are looking for. Whatever x gives us 0 y or positive y. So let's place them in the number line. The smallest number we have the -infinity, the largest number we have is +infinity. And now in the number line, which of these is on the most left side? The leftmost side. Like here, 1, 2, 3. For the first one, which number are we supposed to write? -1. The next number should be? And the last number is? 5. So place everything in the number line we have done here. And now we're going to check each interval. So we have 1 interval, 2, 3, 4. From each interval, we are going to take one number, place into the function to see the y value. So take any number between -infinity to -1, like anything smaller than -1, -2. Let's place it on the equation. So we have -2 squared, -2 plus 1, and -2 minus 5. I don't have space for horizontally, so I'm writing them vertically. And you're multiplying all of these, okay? -2 squared. Do you get a positive thing or a negative number back? Positive number back. -2 plus 1. Do you get a negative number or a positive number? Negative, because -2 is bigger. And then you have -2 minus 5. What do you get? A negative number or a positive number? Negative number. And you're multiplying all of this. Multiply, multiply. So if you multiply positive times negative, what's the end result? Positive. Negative times negative is positive, and positive times positive is positive. And what we are looking for? Positive. Since this interval gives us positive y, we are going to take that in our solution set. So definitely first interval goes in the solution set. Now let's see, what do we get from the next interval? any number between -1 and 0. There is no whole number, right? So to work with fraction, 0.5. Let's say what x is -0.5. So -0.5 square, -0.5 plus 1, -0.5 minus 5. Negative square. What do you get? Positive or negative? Positive. Now between 1 and 0.5, 1 is bigger, right? What sign 1 has? Positive. So we're going to get positive here. And here we have both of them negative. So what sign we get? We are subtracting. We keep the same sign, but we add the numbers. Remember? -1. So this is -5. -5 minus 0.5 gives us negative 5.5. So we have a negative here. 1 minus 0.5, 1 is bigger, so we get positive here. And anything you square always become positive. If you multiply all three symbols, what do you get? Negative. Are we looking for negative? So we cannot take this interval because this interval gives us all the negative ones. So we go to the next interval. Any number from 0 to 5. 3. And I do the same thing. 3 square. Since I don't have much space, so let's do it mentally. We have 3 square. What do we have? 9, which is positive. Then we have 3 plus 1. Positive. And then we have 3 minus 5. Negative, right? Because 5 is bigger. So if you multiply all 3, we get a negative. So we also cannot take this interval. So every number from -1 to 0 gives us negative, from 0 to 5 gives us negative. But what happens exactly at 0? When x is 0, do you get 0y? Positive y? We definitely don't get positive y. But do you get a 0y? When x is 0, what do we have here? 0 square, right? Which is 0. And 0 times anything is 0. So when we have 0, we get a 0y, right? So definitely 0 works in here. The numbers don't work. Anything smaller than 0 or bigger than 0, they don't work. But when exactly it's 0, we have a 0y. The 0 is inside our solution. Even though we have nothing on the left, nothing on the right, but the 0, we have to take it. And now we have the last interval, 5 to infinity. What do you pick? Anything 5 to infinity. 11, okay. 11 square, positive or negative? Positive. Then we have 11 plus 1, positive. Then we have 11 minus 5. If you multiply all of them, we get positive. And you're looking for positive, so we are going to take the last set in our solution. This our solution looks weird. It's everything in this interval, and then 0, and then everything in this interval. So our solution has 3 parts. In the first interval, the yellow part, we have negative infinity to negative 1, right? Negative 1 gets what? Bracket or parenthesis? Bracket, because we have the equal sign. Union. And then suddenly we have 0. Only one number, 0. So for one number in the set, what's the boundary we use? Bracket, parenthesis, or curly thingy? Curly bracket. And then we have our last solution. What is our last solution? What's the set? What's the interval? 5 to infinity. 5 gets what boundary? Which boundary? Bracket or parenthesis? Bracket, because we have the equal sign. Anytime you have an equal sign, the number is supposed to be brackets. Here we don't use bracket because it's one number. For one number is curly. For a set, for an interval, we have to use bracket or parenthesis. Bracket, so let me remind you again. If the inequality doesn't have an equal sign, the number will get parentheses. If the inequality has an equal sign, all the numbers you see, they'll get brackets. But infinity, negative infinity, positive infinity, always get parentheses, always. So this is our solution set. It's the yellow part. Good news? Well, in the finalizer, usually they don't give this. They give the question I told you before, the quadratic. But in the homework, you have this question. And today we don't have time, but we have a rational concept. When you have a rational function like this, these are the rules. They're almost same. The only difference is if we don't have an equal sign, everything gets parentheses. But if you do the equal sign, only numerator gets the brackets. And everything you have from the denominator and infinity, they always have parentheses. So the difference between what you did and what you're going to do is that for rational, the same steps, factor, solve for x. But when you solve for x, you have to solve for x with the numerator and denominator and place everything on the number line and then test it out. So let me do one question quickly. Something like this one, which is already factored. So this question is not factored yet. So you have to see 0, so you bring this on this side, and then you do combination, like you add and subtract with the same denominator, and then you do the same thing. But this question is already factored, so let me show you this real quick. We take everything from the numerator, set them equal 0, everything from the denominator, set them equal 0. We want to see which x values we need in the number line. So we have x squared 0, x plus 7 0, x minus 5 0, x minus 4 0. But we know from before that denominator can never be 0, right? So it's an equal 0. We should write denominator cannot be 0. And we solve x is 0, x is negative 7, x is 5, and x cannot be 4. What type of boundary you're going to have? Bracket or parentheses? Bracket. So this is from the top, this is from the top, this is from the top, and this is from the bottom, the denominator. So this will have bracket, this will have bracket, this will have bracket, but if your solution has a 4, it has to have a parenthesis because it's from the denominator. And what you're looking for, something positive or negative? Negative y and 0y. There are two types of y you're looking for. Which x gives us negative? Also, which x gives us a 0y? So you place everything on the number line. negative infinity, positive infinity, 1, 2, 3, 4. Which of these extremes goes first? -7, perfect. After -7, which one comes? 0. Next. And lastly, 5. The infinity will have a parenthesis, -7 will have a bracket, 0 will have a bracket, 4 will have a parenthesis, 5 will have a bracket, and positive infinity will have a parenthesis. So now check each interval. Take one number from each interval, place here, and see which one gives us -y or 0y. And then do the same thing. You write them in the number line. So definitely not all of them will be in the solution. There will be few in the solution. Which ones are in the solution? You find them by placing them. But this will not be in this exam, okay? In the final exam, sometimes they ask this question, this type. So we're going to go over this before the final. Now let me tell you what will be in this exam. Exactly which question you are expecting to see. So make sure you know them very well. So here, this type. From here, this type. Definitely this. Definitely this, and here this type. So from exam 4, 1, 2, 3, 4, 5, 6. 6 question. I'm skipping 10.5. I wanted to give it, but the exam became too long, so I skipped it. Solving this type. Addition and subtraction, this type. Multiplying is a combination of these. One question where I combine these two. What does it mean? It means I'm going to give, instead of I'm going to give this here. So you first should replace that with I, and then you multiply. Division, I don't remember, but all of these are same, something like this. And also, let me tell you, here I don't have coefficients, but if you see coefficients, all you have to do is simplify these and multiply by the coefficients. Okay, so discriminant. I'm going to ask all three types. I'm going to give you a number. What if your discriminant is negative? What if discriminant is positive? What if discriminant is 0? Then what type of solution you have? How many? How many? And how about the x-intercepts? Okay, so I'm going to give all of these in a table. So you have to find, I'm going to give you a discriminant. For negative, what type of solution, how many, and how many x-intercepts. For positive, like those things. So you have to know all three types. And For factoring, something like this, where you have it A and C. So first step, look for if it's factorable. If it is, then you choose AC method. If it's not factorable, then complete the square or quadratic formula. So this, from the weird looking, I'm going to give you the fourth power. From inequality, one of these. 11.5. Something like this. So if you have 3 terms, you factor binomially. But if you have 2 terms, like only this one, how do you factor this? GCF, right? Or perfect square. So if you have 2 terms, use GCF or perfect square. If you have 3 terms, then you factor binomially. And everything else is same. To find the y-intercept, you set x0. To find the vertex, your x is negative b over 2a. And to get the y, you replace everything into the function, and you get the y value. Transformation, this type. Again, this transformation has 6 points. 1, 2, 3. 3 is for 3 types of transformation. 1 is for original function, original graph. And then 2 is find the vertex. Oops. Come on, vertex. So you have to find the x and y. So for this one, what is your vertex? 4 from the inside and 2 from the outside. So once you graph it, you just have to tell me its vertex is 40. You don't need any math. You just observe and you're doing this. I really wanted to give 6, but I didn't have time. Oh man, I totally forgot to show you this. This time. Since I didn't show you this, probably this is an extra credit, but let me show you real quick. This is actually a final exam question. Final. So you have to know for the final. So what you do in here is a right triangle. So you use a square plus b square equals c square method. Your a and b could be any one of the leg, but c has to be the longest side. Always. So we use, let me show you here. I have it here. So let's say this is A, this is B, and definitely it has to be C. Anytime you see a right triangle, we use A square plus B square equals C square. Our A is x plus 2, so we replace x plus 2 square. Our B is 3, so we replace plus 3 squared. And our C is the hypotenuse, so it's 2x plus 1 squared. And now we have to expand all these squares. We have to multiply them twice. When you multiply, here you get x squared plus 4x plus 4. 3 squared gives us 9. And here, when you multiply twice, 2x plus 1, 2x plus 1, you'll get 4x squared plus 8x plus 1. And now you know what to do. It's a quadratic, so you must bring everything to one side. This 4 is bigger, so let me keep this side, but subtract this. So we have minus x squared, and then we have minus 4x. If you combine these two, 4 plus 9 gives us 13. So we subtract 13 from both sides. So this cancels out. We have 0 equals 3x squared plus 4x minus 12. 4 minus 1 gives us 3, 8 minus 4 gives us 4 positive, and 30 minus 1 gives us negative 12. And then either use factoring or quadratic or complete the square. So most likely it is factorable. If it's factorable, you do AC. So we have 4 and 12, 3 and 12. 3 times 12 is, can you think of two numbers multiplied to 36 combined to 4? Let's see. 12 and 3 doesn't give us, 6 and 6 doesn't give us, 4 and 9 doesn't give us. Anything else? It's not factorable. That means quadratic formula. Negative b plus minus square root of b squared minus 4ac whole thing divided by 2a. So you just replace on negative b is negative 4 plus minus 4 square minus 4 times 3 times negative 12 whole thing divided by 2 times 3. In the exam, you have something that is factorable. So all you do is factor and solve for x. When you solve for x, you only get the positive x because triangle cannot have any negative length. So we have negative 4 plus minus 16, negative and negative turn into positive. 3 times 4 is 12, 12 times 12, 144 over 6. So 144 plus 16, 4 and 6 gives us 10. 4, 5, 6, 160. So negative 4 plus minus and square root of 160. It's 16 and 10, right? 16 gives us 4, 10 doesn't give us anything. So this is 4 square root of 10. And then we can distribute the 6 to both so that we can cancel. Both of these are divisible by 2. So 2 goes to 4 twice and 6 3 times. 2 and 3. So our answer is only the positive one. Negative 2 plus 2 square root of 10 over 3. We cannot take minus because when it's minus, we get a negative x value, but we cannot have negative because it's positive. So in real life, our x cannot be negative. So again, in the exam, it's factorable. So all you have to do is factor, and if you have a negative x, don't take it. That's all you have to do. Any question? So total is 19 questions. You have 1 hour, 30 minutes. And few of them is non-multiple choice. Few of them are multiple choice. So 3 pages non-multiple choice, 3 pages multiple choice. Okay? Good luck, everyone. Remember, Thursday, there is no class. The Thursday class we are going to have next week, Friday. This Thursday, there is no class. This Thursday. The Friday, and you're going to come here Friday to take the exam. And then whatever we are missing on Thursday, I'm going to make up on Friday. Friday is an online class. You don't have to be here. So good luck, everyone. If you have any question, email me anytime. Number line. Yeah? It's incomplete, okay? You're going to complete the rest. The last number line we use is this. So see, we have to pick a number from each interval, substitute into the original function, then observe the sign. So I didn't do all of these for the next one. We are going to do it, and if you want to know the answer, email me to work, and then I'll tell you if they're correct or not. Not less than, so You're looking for positive or 0, 1. Pick any number less than negative 1. So it is negative 2 less than negative 1 or greater than negative 1. Here, pick anything between negative 1 and 0. There is a whole number, so you can do this in one. It's negative 5 and 0 is negative. And then from 0 to 5, pick anything, any number from 0 to 5, break it to. So for this question, any number smaller than 0, you can pick anything. What do you want to pick? Negative 3 is not smaller than 7.
Oh, negative 0. Negative.
Negative 9. And then any number between negative 7 and 0. Negative 3. Anything between 0 and 4. 2. Anything from 4 and 5. It has to be decimal. There is no whole number. 4.5. And then anything bigger than 5. 8. So what you're going to do is you're going to place all of them into the question. So question is x squared plus times x squared times x plus 7, x minus 5, and you're dividing by x minus 4. So if your x is, it is all of these x's, because we are going to replace them with the number you're looking for. The first number is negative 9. So if you replace negative 9, negative 9, negative 9, negative 9 with all the x's, negative 9 squared gives you what? Any square becomes positive. Negative 9, positive 7. What do you get? Which one is bigger, 9 or 7? And what sign 9 has? That means it has to be negative.
Oh, so we're just looking for the value?
Only the sign, not the number. And the last one, negative 9, negative 5. You're not multiplying, you're adding them.
Oh, negative.
Negative. On the denominator, negative 9, negative 4. Negative. So you can cancel one of the negatives, and then from the rest two, what sign you get?
Oh.
And here you're multiplying, because all of these multiplying and the division. Negative. And what you're looking for? Negative y. So this is negative, so you're going to have this in your interval, because this is negative. You picked negative 9 and you got the y value is negative, and you're looking for negative y value. So this has to be inside your solution set.
Oh, okay. So after, you just like.
From the number line, you highlight what goes inside the solution.
Oh, just figure out.
Exactly. For the next one, you pick negative 3. So let me erase all of these and turn them into negative 3. Negative 3, negative 3, negative 3, negative 3. So negative 3 squared, positive. And now between 7 and 3, which one is bigger? What sign 7 has? Positive. Now between 3 and 5, negative. And then on the denominator, negative. We cancel the negative, so the result is, so this gives us positive. Are you looking for positive y? No. So we cannot take this in the solution set. So this is our second interval. Now our next interval is 2. Point x is 2. Let me erase all of this. All of these becomes positive 2. So 2, 2, 2, 2. X is 2. So what is your symbol? 2 squared. Positive. And then 2 plus 7. 2 minus 5. Denominator 2 minus 4. Negative. We cancel the negative, the answer is positive. So this is positive, but are you looking for positive? No. So none of the interval gives us positive, negative, but when x is 0, we have y0, and you're looking for also 0, y. So you're not taking the two intervals, but we have to take the middle one. Okay, then we go to the next one. Next is 4.5. So we erase all of these to 4.5. 4.5, 4.5, 4.5, 4.5. Now 4.5 squared, so x is 4.5. 4.5 squared, positive. Now between 7 and 4.5, positive. 4.5 and 5. Which one is bigger, 4.5 or 5? 5. What sign 5 has? Negative. And on the denominator, 4.5 minus 4. Positive. So by adding and multiplying and dividing all of these, what result we have? Negative. We cancel the positive, so we're left with plus and minus, negative. So this is negative, and we're looking for negative. So can you take this interval? So we highlight this interval. And then lastly, we have one more interval left where our x is 8. So we replace all of these x values with 8. 8, 8, 8, 8. 8 squared. And then we have 8 plus 7. And then 8 minus 5. 8 minus 4. All the positive gives us positive. Are you looking for positive? No. So what is our solution? Negative and 0. If it's only less than 0, you're looking for only the negative. If it's only greater than, it's positive y. If it's greater than or 0, it's positive y or 0 y. So see the three things I highlighted, these are our solution. So first interval is from negative infinity to negative 7. Now negative 7 we got from the numerator, so we have to have a bracket because we have an equal sign. Infinity always gets parentheses. And then our next solution is only one number, 0. So for one number, we use curly brackets. And then our last solution is between 4 and 5. Now 4 we got from the denominator. So it has to have a parenthesis. Denominator and infinity always get parentheses. But 5, we got it from the top. So it has to be brackets. So this is our solution.
Okay. So basically, so these type of problems is like you find the x values fast and each check them and finding the y.
We substitute into the function to see the y. And then whatever gives us what you're looking for, positive or negative, then we take them in the solution. Whatever doesn't satisfy what you're looking for, we cross them from the solution.